So this video is a collection of 3 questions about Maclaurin series, and what I would like you to do in the first question is to calculate the first 4 non-vanishing terms in the Maclaurin expansion of 1 over 1 plus x, and then multiply your result by 1 plus x to check your work. The second question is to use your result from the first one to write down the Maclaurin expansion here immediately. And the third question is to calculate the first 4 non-vanishing terms in this Maclaurin expansion and then square your result to see that you have done it correctly. The next slide contains answers, and after that, if you require more detailed feedback, there are detailed solutions in the rest of the video. So what I suggest is that you try to do these with pencil and paper and then pause the video now. Okay, welcome back. Let's look at the next slide with the answers to these questions. So here are the answers to the questions. The Maclaurin expansion of 1 over 1 plus x is 1 minus x plus x squared minus x cubed, and this pattern continues on forever, but this is the accuracy that was asked for. So we write here it's this plus terms of order x to the fourth. And to check our work, we can take this expansion written here, multiply it by 1 plus x, and if you multiply this by 1 plus x, you get 1. So here we should also get 1, and we do get 1 plus terms of order x to the fourth that we have not calculated and do not know anything about. If we have this expansion for 1 over 1 plus x, then we can immediately simply replace x here everywhere by minus x, and that gives us this expansion for the Maclaurin expansion of 1 over 1 minus x. Finally, the Maclaurin expansion of the square root of 1 plus x is written here, plus terms of order x to the fourth. And to check our work, we take this result, square it, and if you square the square root of 1 plus x, you get 1 plus x, and in a similar way that's exactly what we find, plus terms of order x to the fourth that we don't know anything about because we've not written them down here. Okay, I hope you have got those correctly, but if you have any questions about it, any of the details, the rest of the video contains the answers in turn. So let's move on to the answers to this question now. So, in the first question, we are asked to calculate the first 4 non-vanishing terms in the Maclaurin expansion of 1 over 1 plus x, and let us recall and write down explicitly the formula for the Maclaurin expansion. So this is a polynomial, and of any particular function, f of x, in this case this is our function, we evaluate the function at 0, and then we add x times the first derivative of the function evaluated at 0, plus x squared over 2 factorial times the second derivative of the function evaluated at 0, etc., as far as we want or need to take it. So this is our expression, and our function f of x is 1 over 1 plus x, and that of course can be written as 1 plus x to the power of minus 1. And I think that's extremely useful to do it because it will make the differentiation a lot easier. Now, this means that our function evaluated at 0, remember that's the first term we're going to need here, is just this with x put to 0, so it's 1 to the minus 1, which is of course just 1. We now need for the next term to calculate the first derivative, and the first derivative is going to be, let's look at it written this way, we bring the minus 1 in front, reduce by 1, so that's going to go to minus 2, and then we multiply by the derivative of 1 plus x, but that is just 1. So all we're going to get is minus 1 plus x to the minus 2 multiplied by 1. So I won't bother to write that. And now when we put x is equal to 0 in the first derivative, we evaluate the derivative at 0, we have minus 1 to the minus 2, so it's minus 1. So this is minus 1. And in a similar way, the second derivative, which is the derivative of the first derivative, well, we're going to bring the minus 2 in front. Minus times minus 2 is 2, and then we have 1 plus x to the minus 2, reducing that power, goes to minus 3, and then again we multiply using the chain rule by the derivative of 1 plus x, but that's just a factor of 1. So we have plus 2 times 1 plus x to the minus 3, and that means that the second derivative evaluated at 0 is plus 2. And then we can repeat this for the third derivative, and that means bringing down a factor of minus 3. Minus 3 times 2 is going to give us minus, and now 3 times 2 is 6, but I'm going to write it as 3 factorial, and then it is 1 plus x to the minus 4, and this tells us that the third derivative evaluated at 0 is minus 3 factorial. Now the question asks for us to calculate the first 4 non-vanishing terms, and each one of these terms is non-zero, so we can stop this part of the calculation here. And all we need to do is to substitute these values into our equation, and that's going to give us the result. So therefore we see that the Maclaurin polynomial for our function is the function evaluated at 0, and that's 1. So we have 1, and then we have plus x times the first derivative, and that's a factor of minus 1, and then we have plus x squared over 2 factorial times the second derivative, which is 2, and of course 2 is the same thing as 2 factorial, and then we have plus x cubed over 3 factorial times minus 3 factorial, and then there are other terms that we're not going to calculate here, so there are terms of order x to the power of 4 that we are not taking into account. So if we now just tidy this up a little bit, what we see is that the Maclaurin polynomial is 1 minus x because of this. Here this and this cancel, so we have plus x squared. Next, the 3 factorials cancel, but there is a minus sign, so we get minus x cubed, and then there are terms we've not calculated of order x to the power 4. So that is our answer, and these are the first 4 non-vanishing terms in the Maclaurin expansion of 1 over 1 plus x. So what we can do now is to check this, and our check is going to be, let's multiply the polynomial by 1 plus x, and if the polynomial is correct and is a good representation of 1 over 1 plus x, the polynomial and 1 plus x will cancel up to terms of order x to the 4th that we have not yet calculated and don't have any knowledge of. So what we have is 1 minus x plus x squared minus x cubed plus order x to the 4th times 1 plus x. And I think it's useful to be quite explicit here that there are terms of order x to the 4th that are not written down in our expansion. So now when we multiply this out, what we are going to get is 1 times all of this, and then we will add x times all of this. So we're going to get 1 minus x plus x squared minus x cubed plus terms of order x to the fourth, and then we get plus x times 1, so the x times the 1, minus x times x is minus x squared, and then we have plus x squared times x, so that is plus x cubed, and then we're going to get from minus x cubed times x and minus x to the fourth, but there are other terms of order x to the fourth that we don't know, so there is no point in writing x cubed times x. I'm just going to leave that in the unknown plus order x to the fourth terms. So now looking at this, we see that there are some cancellations. The minus x and the x cancel. Similarly, the x squared term and the minus x squared term cancel, and also minus x cubed and plus x cubed cancel. So we obtain, as we would hope, that our polynomial times 1 plus x is 1 plus order x to the fourth, which is just an expression of the fact that our polynomial is only known up to terms of order x cubed. X to the fourth terms are not known. So this is as expected, and it shows us that our result is correct. So what we did, just to repeat it, is we recalled the key formula and we tried to structure here our approach. The function written in a way that makes it easy to differentiate, the function evaluated at 0, the first derivative evaluated at 0, etc., until we had 4 non-vanishing terms, which is what the question asked us to provide. We then substituted these into the formula, and that gave us our result, and we have the logical simple check that if we take our expression, multiply it for this function by 1 plus x, we should get 1 up to terms of order x to the fourth, and that's exactly what we got. So with that, we will move on to the next exercise. In the previous question, we calculated the Maclaurin expansion of 1 over 1 plus x, and the second question asks us to write down the Maclaurin expansion of 1 over 1 minus x. So to do that, we just realize that we can write 1 over 1 minus x as 1 over 1 plus minus x. And the minus x here plays the role of the x here. So we can take this formula and replace x everywhere by minus x, and that will give us our result. So therefore, 1 over 1 minus x is going to be 1 minus, and now not x but minus x, plus minus x squared minus, and then minus x cubed plus order, and now x to the fourth, but that can also be minus x to the fourth, but that's the same thing as x to the fourth. So again, just to talk about this a little bit more, the 1 has not changed. Here we have minus x, and now we replace that x by a minus x here. Here we have plus, and then the x squared becomes minus x squared. The minus sign is here, and then the x cubed becomes minus x cubed. And once we just tidy that out a little bit, what you see is you get 1 plus x squared on the squaring, and then here there are 1 and then 3 more, so 4 minus signs, so it's plus x cubed plus order x to the fourth. So this is our result, and we can stop the exercise there. And very generally, this idea of replacing the x by a minus x in this form, We could expand that, we could look at problems such as, so more generally perhaps, you might have a higher power, so you might say that 1 over 1 plus x squared, you could write it as 1 over 1 plus, and then call this x squared, and then x squared you see here plays the role of x here. And you're welcome to try to calculate it explicitly to check, but what you will get is 1 minus x squared plus x squared squared minus x squared cubed, etc. So this is 1 minus x squared plus x to the 4th minus x to the 6th, and then the next term that one would get would be of order x to the 8th. I'll leave that to you as an exercise to check. But what I'm trying to say with this is that a formula like this gives you information about other expansions, and with that we'll move on to the final exercise in this quiz. So the final exercise in this video quiz is to calculate the first 4 non-vanishing terms in the Maclaurin expansion of the square root of 1 plus x, and again we recall our key formula. So here our function f of x is the square root of 1 plus x, but because we are going to be differentiating this, it's useful to write the square root as 1 plus x to the power of a half, and this tells us that our function evaluated at 0 is the square root of 1, and that is, of course, 1. The first derivative of the function as a function of x is a half times 1 plus x to the a half minus 1, or minus a half. So the first derivative evaluated at 0 is a half multiplied by 1 plus 0, which is just 1 to the minus a half, and 1 to any power is 1, or any real power. So our second derivative as a function of x is going to be a half times minus a half, so this is minus 1 over 4 times 1 plus x to the minus 3 halves. So our second derivative evaluated at 0 is minus 1 quarter. 1 plus x when x is 0 is just 1, and that's just going to give us a factor of 1. Our third derivative is going to be, so now we have minus a quarter times minus 3 halves, so it's plus. We're going to get 4 times 2, or 8 on the bottom, and 3 on the top. So it's going to be plus 3 eighths times 1 plus x to the minus 5 halves. So our third derivative evaluated at 0 is 3 eighths multiplied by 1. So we have 4 terms here, all of which are non-zero, and for the purposes of this quiz we can stop our work here and substitute these into our formula. So this tells us that our Maclaurin expansion of the square root is going to be our function at 0, and that's 1, and then it's plus x times our function's derivative evaluated at 0, and that is a half, so we're going to get plus x over 2. The next term is x squared over 2 factorial multiplied by the second derivative evaluated at 0, so that's minus a quarter times the 2 factorial on the bottom, so we're going to get minus 1 over 8. So we have minus x squared over 8. And then the next term is x cubed over 3 factorial times the third derivative. The third derivative is positive, and it has a 3 on the top, which will cancel with the factor of 3 and 3 factorial. There's a 2 left on the bottom, and the 2 times the 8 is going to give us overall a factor of 16 on the bottom. So we get plus x cubed over 16, and we stop there with an uncertainty about the form of the term of order x to the fourth. So this is our answer for the Maclaurin expansion. Now, if you take the square root of 1 plus x and you square it, you should get 1 plus x. So in a similar way, we can carry out a check by taking our polynomial 1 plus x over 2 minus x squared over 8 plus x cubed over 16 plus unknown terms of order x to the fourth, and if we square this whole thing, we should get 1 plus x plus unknown terms of order x to the fourth. So let's just verify that that happens to check that our expansion is correct. So here we have something plus something plus something plus something, and we are squaring it. And when we do that, we'll get this squared plus this squared plus this squared plus this squared plus 2 times this, 2 times this times this, this times this times this, all the possible cross terms. So let's just try and do that in order. So what we're going to get is 1 plus x over 2 squared, and then when we square the next term, we are going to get x squared over 8 all squared, but that's going to be of order x to the fourth, and there is also going to be a cross term of 1 times x to the fourth, so there's no need for us to write down the square of this. What about the possible cross terms? Well, we can have 1 times x over 2, and there will be 2 ways of getting that when we expand this. So we're going to get plus 2 times 1 times x over 2. We are also going to have 2 times 1 times x squared over 8 with a minus sign, so that will give us minus 2x squared over 8, and we're going to get plus 2 times x cubed over 16, and then we're going to have the 1 times the x to the fourth unknown terms, so that's going to give us terms of order x to the fourth that we don't know explicitly. So the terms we have here, this came from squaring that, this came from squaring that. All the other squares are of higher order, we don't know them. And then we've got this times this, 2 ways of getting it when we expand this. This times this, 2 ways of getting it. And this times this, 2 ways of getting it. But we also have this times this. And there are 2 ways of getting it when we expand out such brackets. So we're going to get plus 2x over 2 times minus x squared over 8. That's also a term of order x cubed, so it should end up cancelling to just give us 1 plus x. And the next term would be x over 2 times x cubed. That would give us an x to the fourth term. There's no need to write it down. There are terms of order x to the fourth that we don't know. So let's just tidy this up a little bit. We're going to get 1 plus x squared over 4. We're going to get plus x, where the 2 and the 2 on the bottom here cancel, and the 1 plus x is exactly what we want when we square the square root of 1 plus x, so we're very happy about those terms. This term is going to have to cancel. And let's look now at the next term. We have minus 2x squared over 8. The 2 and the 8 will partly cancel, so that's going to give us minus x squared over 4. And that's excellent because that and that term cancel. And now we have plus x cubed over 8 because the 2 and the 16 partly cancel. Let's not write this immediately. Let's now put it at the very end of the line. Let's just look at this term. We have a minus sign, the 2's cancel, and the x times the x squared gives us x cubed, so we have minus x cubed over 8, which is excellent, because that has to cancel the previous term, so this and this cancel. And then there are the unknown plus order x to the 4th terms. So therefore, the square of our Maclaurin expansion, if we take our Maclaurin expansion and square it, we get 1 plus x plus unknown terms of order x to the 4th. And that's exactly what we would have wanted. So we see that our Maclaurin expansion for the square root of 1 plus x is correct. And with that, I will stop this video.